Welcome to this SQL on Azure webinar. My name is Mike Martin and I'm also replacing Carlo Cunha. So basically this talk is about Microsoft Azure Platform and everything SQL related in the Microsoft Azure Platform. So as you know, the Microsoft Azure Platform is a vast environment ecosystem delivering you infrastructure as a service solutions and platform as a service solutions built upon the Microsoft Cloud infrastructure. Don't forget that the Microsoft Azure Platform is run all over the world within 19 regions, 19 large data centers, which allow you to host either infrastructure as a service based on Windows VMs or Linux VMs upon the mighty storage layers that Azure offers. Next to that, we also have the platform as a service offering, which allows you to rapidly deploy web solutions and web apps, but also a lot of data solutions and analytic solutions by means of Azure Insights and stuff like that. The cool thing about Microsoft Azure is that you have a lot of tooling that you can connect to the Azure platform that you already know inside the .NET platform, the .NET framework, which you can use or misuse to your needs, integrated with either Visual Studio or even Eclipse for when doing Java. It has a continuous delivery platform built upon the Git and the Team Foundation service, which is also very widely used and spread. If you're more into an open world, you also have full support for everything which is related to Java, Node.js, PHP, Python, Ruby, C++, and so on and so on. So there's something to be found for everyone inside the platform. Now, knowing that it is a cloud platform, you know that in the old days we used to do everything ourselves. So on premises we had a full stack, we had a rack that was driven into the data center in which we had to maintain everything, starting from the networking stack up until the storage stack, adding disks at runtime and so on and so on. On those disks we started running our hypervisor servers on which we virtualized new machines where we had to maintain the operating system and every middleware runtimes up until to the point where we could deploy our applications and maintain our data. Now with the coming of cloud, and whether it's private or public, doesn't matter, you can have basically three different forms of cloud. You can have the three different models as we know. First you start off easily by doing infrastructure as a service, where the vendor provides you a virtualization stack upon which you can deploy and roll out your virtual machines, of which you have to do the full management yourself. So that means you deploy a VM, you have to patch it yourself, you have to deploy and maintain all the middleware and all the runtimes like the .NET framework or even a SQL ODBC driver or something like that, and up until the point where you need to deploy your applications. That can be anything basically. Now, as a platform as a service, the vendor, or in this case Microsoft, offers you a platform where you just need to deploy your data in your applications, and everything underneath that is being managed in a fairly scalable way. You have the advantage here that it scales upon nearly infinity. You know that infinity is limited by the capabilities of the platform itself, meaning that you can have only as much as VMs that you can have in a data center. So trust me, it's fairly unlimited, but still there's a lot of there's still infinite scale is only limited by the scale of the data center itself. So maybe a false premise, but something to keep in mind. And I have software as a service, where you actually do nothing more than just configure your application and you just rent the software that you need. The best example here is something like we all use, like email on Outlook.com or Gmail or Dynamics CRM or Office Online, Office 365. although Office 365 is maybe a little bit a more hybrid scenario, but it works mostly as a software as a service. Okay. Now, if we talk about SQL Server and SQL related things, we can see that there's been a growth and an evolution in the entire platform. And basically, we're going to focus in this talk on two things: infrastructure as a service and platform as a service, where we talk about SQL Server deployed in Azure or next to Azure, and also as platform as a service, meaning Azure SQL databases running as a SQL database server in Azure itself. So let's get started with Azure Virtual Machines on SQL Server. Azure Virtual Machines with SQL Server, you have the full benefit of running a full SQL Server inside Azure by benefiting the infrastructure as a service offering, in this case by Microsoft, of course. And that means that you also have a full control over your SQL Server itself. So you're fully responsible of the entire stack, meaning that starting from the OS up until the part where you tweak and tune your SQL Server itself. And all the same rules that you have on-prem apply also in this environment. So it's not that when you're deploying to Azure that all of a sudden everything starts running automatically. You need to keep in mind all the tweaking and performance tricks that you know from on-prem. You need to apply them also in the environment of Azure too. Now, when you want to deploy Azure SQL Server VMs, there's two ways of doing that. You can either do it by installing it yourself on virtual machines that you select by using the SKUs that they have available. So what you do is you pick your menu option and you deploy that VM, and 8 minutes later you have a bare bone VM that you can start using, and for that you can start deploying your SQL Server on top of that. Now, coming with this, you also have the possibility to deploy your own version of SQL Server with bring your own license, which is allowed only when you have software assurance. And for that, you can just deploy any kind of SQL Server that you already have in-house. Now, selecting a size is limited only to the choices that you have in Azure, so you cannot choose your own settings there. You can only have choose from a fixed set of settings. This means that you can choose between X number of cores that you can have available combined with sizes of memory that you have. Like for instance, the thing that you see on the presentation now is the definition of the G series, or what we call the Godzilla series. These are high memory instances available for your needs, and when you run them, you get an availability of 2 cores. For the G1 standard, for instance, and the availability of 28 gigabytes of RAM. Also, immediately there's a deployment of 4 data disks immediately attached when you deploy this. This can of course be expanded to your needs. Disking is only limited to 32 disks when using high performance and primary. We're using high performance storage, so the new storage layer, and then you can go up to 32 disks. Elsewhere it's limited to 16 disks if you're not doing it in that new storage sizing. And the cool thing is that when you're running more disks and you stripe them, you get more than just the IOPS that you have by 500. So every data disk that you add and you stripe them, you get the number of data disks times 500, and that's your number of IOPS. So the more disks you have, the faster your environment will run. Now, next to that, you can also have a possibility of running a Microsoft Azure SQL Server, Microsoft SQL Server immediately pre-installed into a virtual machine by the means of the templates that you have in the Azure Gallery. Now, this comes with the same settings as a VM, only this time Azure SQL Server comes pre-installed, and it immediately comes with a license cost. Hence why there is a difference between the pricing on this page and this page. You see, actually it says G1, the same machine. It's the same machine definition. The only difference here is that you also pay the license for SQL Server. So in this case, you pay about 900 euros more per month for maintaining your SQL Server license. That doesn't mean that you don't have to tweak your SQL Server instance anymore. It's just your license that you're paying. It doesn't mean that it's optimized for that machine. There's some things that have been optimized, but everything for your database and your application still needs to be tweaked. So it's an out-of-the-box installation, only a little bit optimized for running in a virtualized environment. But that's it. Everything else is just still up to you, and you still need to maintain every other tweaks as you do in a normal on-premise environment. Okay, so that's something very, very important to keep in mind. Yeah? So out of the box doesn't mean that it will run as designed in your environment or on-prem. What happens is, if you deploy a SQL Server, it will actually use a sysprept environment. It will reinitiate every single setting, and 8 minutes later, or in this case 12 minutes later, a full SQL Server will be at your disposal, and you will be able to use every feature. Yeah. So you still need to deploy your own application, your own databases, and by that you can just connect to it by means of the SQL Server Management Studio from within the VM, or even remotely connected if you want to. Now, when you connect to your instance, there's a couple of things to keep in mind also. You need to make sure that if you're doing deployments of VMs, that you open up every possible endpoint that you need to be using. In this case, if you want to make it publicly available, you need to open port 1433 on the inside, and a public port which is obfuscated if you want to make it a little bit more secure. But you also need to make sure that you open up the firewall on the machine, because the Windows firewall is instantiated and is active. So you need to make sure that all connectivity options are open on both the outside and on the inside. By default, there's already a port netting foreseen, which we call an Azure endpoint, which nets a public port to a private port, which are most of the time different port numbers, right? And there's two default ports created already. That's one for RDP, Windows Remote Desktop Protocol, and for PowerShell. And the RDP port automatically gets an auto number, but for most environments this isn't sufficient. Most environments don't allow RDP over different ports and over 3389, or it could be that you need to use a totally different port in your environment because your firewall on the premise side doesn't allow connectivity to RDP2, so you need to keep that in mind. 1433, which is the default port for SQL Server, needs to be opened as well if you want to make it available to the developers, or actually to the end users itself. Right. Now, if we talk about SQL databases, if we talked about deployments on VMs, if we talk about SQL databases, you have a totally different setup. For starters, a server is not a machine. What do I mean by that? Is that a SQL server that we have today on premise, that's a full machine. You have a Windows, and on top of that there's an application layer running SQL Server, right? Now, SQL databases servers in Azure are totally different. These are tabular data stream endpoints, which are actually database servers being run in SQL databases. Yeah. It's a little bit confusing, but the reason why I'm saying this is that a SQL Server database on Azure actually doesn't allow you to do all the full functionality that you have in a SQL Server run in a VM or on-premise. There are some limitations there, some things that you cannot use, like for instance some functions, some T-SQL functions that you have. You don't have access to all the sys databases, you don't have access to everything in the master database, and so on as well. Yeah. If we take a look at the architecture itself, well, on top of everything else, you can just connect to it like with any normal application, like you used to now in normal SQL Server environment. So what you can do is you can connect to PHP by means of the PHP drivers or the Zen framework, but you can also easily connect with your SQL Server Management Studio, Access if you want to. God knows why you want to do that, but hey, there's a possibility there. You also have WCF data services that you can build on top of that, and if you really want to connect, there's the normal drivers that you can use to connect to it, either by means of ODBC or ADO.NET, which works like a charm, right? Those really connect up on top of the tabular data stream. It's just the same as you output a SQL Server, so that's also the tabular data stream if you're connecting to a SQL Server, but only limited to the database itself and only limited to the capabilities that the SQL Azure databases have. Now, luckily, the new version v12 exposes a little bit more functionality of SQL Server in comparison to the earlier editions. So you now have more of the features that you have in SQL Server available in SQL databases on Azure. Luckily for us, right? That tabular data stream, what it actually does is it creates a layer, and it connects through an SSL. So it actually is a secure socket layer that it connects through, connects to the services layer, and that services layer is actually there to provide you a better experience especially when doing or designing multi-tenancy applications. So what it has is the services layer is there for provisioning databases in the SQL Azure database server, right? But also billing and metering. So you can see performance gauges, and you can see exact how much one database will cost, how much one of your customers actually is consuming, and that they need to pay or that you need to re-incur on their invoicing. Like for instance, if you have a software as a service, right? Next to that, you also have connection routing, so that way you can have a high scalable database which does elastic sharding or failover if you want to. We'll talk about that a little later. But it's important to know that everything there is actually moving in a fluent way without you noticing it. So you don't need to provide any means of communication skills there or communication code there that's been done automatically. Yeah. Now, it also provides automatic failover. It provides scalability, and so on and so on. So underneath that you have the platform layer, which actually is an instance of the Azure Fabric, yeah? And for that we have a special fabric which is called the SQL Database Fabric, and that really manages everything, starting from provisioning the SQL database servers in Azure to automatic failover to replication when it's necessary in Geo, and it replicates between different physical servers. So that's a layer on top that's been running, and you actually don't see what's going on there. But if it wasn't there, then your database would just be a single instance and nothing would happen there. Also, keep in mind that when you deploy a SQL Azure database, or Azure SQL database, you also get 3 copies. So deployment of a SQL database on Azure is actually replicated 3 times, even on a local setting. Hence why if something happens there, you don't see any downtime practically. You just have maybe discover a little bit of latency of a few seconds, but that's the only thing that you will notice, right? Afterwards it just runs over because it's replicated really fast on storage layer level, so that's a cool thing. Now And underneath that, it's running on the same infrastructure layer as everything else in the Azure or Microsoft Online services. It runs in the same data centers as Azure is running. It's managed through the same fabric layer. It's managed with the same way we do high availability, same way of failover, and so on and so on. Yeah. Now a little bit deeper on the Azure SQL database itself. So it's a relational database as a service. It's fully managed by Microsoft. And it's built for elastic scale and performance. So you can easily scale up and scale down, or scale out or scale in. You have a good dashboard view with database metrics. You can easily tweak your throughput if you want to, depending on the SKUs, which we'll take a look in the next slide. But also the improvement there has been done since V12 on better self-service restoring and disaster recovery, and also the compliance enablement is even bigger than before. On compliance, if you're doubting that your data will be safe in the cloud, don't doubt. Microsoft has put a great effort in the thing we call trustworthy computing, and they actually are the onlyest platform that is compliant with most of the things that we are demanded by today in our own data centers. Things like PCI, SOX, ISO compliancy, but also HIPAA, even FedRAMP if you need it. Also, when doing geo-replication, your data never leaves the European Union unless in case of an issue where Microsoft says, can we copy the data to our own data centers to evaluate and investigate eventual issues. Yeah? But that's the only point in time where, unless you do it yourself of course, where Microsoft actually copies it outside of the European data center. So that's a good thing to know. So that way you're a little bit more safe. So it's bound to the safe harbor principle, so you're good to go there. Yeah. And next to that, you also have self-manageability on the entire platform with programmatic APIs, so you can just connect to the APIs and start building on top of those with the tools that you know in the languages that you know today. So there's nothing more to learn than just the exceptions of the things that you can't do, but anything else you can do. Yeah. Now, taking a look at the tiers that we have today. So before we had two editions called Web and Business Editions, which had an SLA of 99.9%, so 3 nines. Now the new SKUs have a better availability. They have 4 nines availability, so it's a much better SLA. And the difference only varies in the sizing of your databases, the performance, and the continuity. Now they're all very secure. Yeah? Only basic, it's a little bit less high available. Less highly available is mildly put. The availability is the same, but it's the ways that you can restore are different, and the performance is also for lighter transactional loads. Where the premium can have high throughput, up to 500 gigabytes of databases, which can be partitioned again, so you can have multi-tenancy applications, but also business continuity wise, there's much more features that you can use, like very point in time restores more granularly and stuff like that. So there's a lot of different tweaks there that you can do to maintain your business continuity there. Now, when talking about integration, there's a two things that you can do. You can just connect to either a SQL database or a SQL Server on Azure as a VM, which allows you to just use the SQL Server itself. But there's different ways on connecting. I already explained the endpoints. But you can also have an integration through the means of a hybrid scenario. Now, these hybrid scenarios are being set up by means of either a virtual network to virtual network connectivity, which we call region to region networks, and that means that you can deploy multiple VNets into Azure, and where you deploy multiple Azure virtual machines. We're talking about the infrastructure as a service here, so not the real PaaS offering, where you can deploy multiple virtual machines, either in an always-on solution or anything else that you have as a disaster recovery or failover solution for or high availability solution for SQL Server. Next to that, you can also have a full hybrid scenario on which you can have a start light with a point-to-site SSL gateway. Now, this is only good for developers doing ad hoc or uploading stuff or connecting to the database for developing stuff. Don't do this as a production gateway because the timeouts aren't stable. There's things that you can tweak, but it's still low throughput and stuff like that. So it's only foreseen for ad hoc connections and not really for full connectivity on a long term. If you really want to do that, you better take a look at site-to-site connectivity through means of a VPN. Today, lots of devices are supported on the on-premise side. Cisco has most of their devices certified for Azure. There's a certification for Juniper. Also, WatchGuard is being offered as a gateway device, but also also Windows Server 2012 and 2012 R2 RAS is fully supported. So if you're deploying a gateway and you want to connect through RAS, there's a deployment script by means of PowerShell that you can use to connect your on-premise infrastructure to the virtual network in Azure, so that way you can set up a gateway between the two. If you really want a high-speed connection, well, there's this one more level up which we call ExpressRoute, and you can actually see it as a direct link to Azure. It's being offered through many SPLAs, many MPLSs, so telcos, and actually all of them are available here in Belgium. So you can either connect through an MPLS, or you can connect through a data center where the MPLS is already in place, and that way you can have a direct link to Azure with bandwidth up to 1000 Mbps guaranteed. So that's the largest speed that you can offer there. Now, next to that, you can have a lot of capabilities going through Azure. So you have you don't only use Azure as a solution for running SQL Server, but you can also use it as a solution for offsite backup solutions. Well, there's a couple of features that you have in SQL Server or in Azure SQL databases that you can use to back up to the cloud. First of all, you can start by backing up your full MDF files by means of Azure Backup Vault, which is a backup solution created by Microsoft for running Windows NT backup on machines, and they automatically get back up to an Azure blob storage. Yeah. Then again, you also have the triple replication of all the files that are being stored in the Azure blob, so that's also an advantage that you have here. But that doesn't do anything really of real backups to SQL Server. That can only allow you to move every backup file that you created with SQL Server to the cloud. So that's also a solution, right? That's the first step that you can do. You can now also have a full backup through that same mechanism of your VM in Azure. So you can just do a full bare metal backup of the SQL VM if you want to. That's a new feature released a couple of weeks ago. What you can also abuse. Very impressive what you can do with that. Maybe a good thing to take a look at too. Now, out of the box, SQL Server 2014 also has a couple of features there. There's the backup to the cloud feature that you have, and what you do there is that from within SQL Server, you just immediately can back up to Azure Blob Storage. So instead of using a tape or a disk, you just connect to the URI, and through means of a secure socket layer and a certificate connection, you can actually have a full backup being stored on the URL. So that's a very cool thing. You have archiving there, so it's a better alternative than tape. In this case, tape is, although a lot of you guys still probably do it on tape, but this is a far cheaper and far more stable environment than tape itself. So there's this option in SQL Server itself. The cool thing about backing up to the cloud immediately is that also the cost price of the blob storage is very, very low. So that's another advantage that you have here. Now, when talking about managed backup, that's a new service that you have in SQL Server 2014, and this can also be done in Azure SQL VMs. So that's a very cool feature that you can use there. So SQL Server Managed Backup to Windows Azure manages and automated SQL Server backups to the Windows Azure Blob Storage also. You can have a strategy based upon retention period and transaction workload on the database. So that's a very cool feature. It also supports point-in-time restore for the retention time period specified, so that's also a cool thing. And it can be enabled at a database level or at the instance level to manage all the databases on the instance of the SQL Server. SQL Server can be run on premises or in a hosted environment like Azure itself, of course, like in an Azure virtual machine. And it is recommended for SQL Server running on, it's really recommended for SQL servers running on Azure. The main interface to interact with SQL Server Managed Backup is of course Transact SQL. These are system store procedures that are used for enabling, configuring, and monitoring the SQL Server Managed Backup. And some system functions are used to retrieve existing configuration settings, parameter values, and etc. To get more information on the backup information. There's also extended events that are used to surface errors and warnings, so you have a good overview of what's going on between all the machines and the storage itself. And there's also the capability to have alert mechanisms by means of agents, agent jobs, and policy-based management. So it's also a cool thing. Well, and you can have either full database backups or transaction log backups. So those are the two things that you can actually do here, right? Now, for SQL Server databases in Azure, there's actually a full backup mechanism already in place, which happens automatically from the moment you enable a database in Azure. So what happens there, if you get this oops moment on a Monday morning, and you delete all the salesperson quota history from the sales table, well, you forget to put the where statement, well, that's an oops moment, right? Those are those Monday mornings that you just would have stayed in bed, prefer to stay in bed than do anything else. Now, luckily, Azure SQL databases have a point-in-time restore that you can have, and you just look up the point-in-time restore database. You restore it as a secondary database, and then you can start exchanging data with the fields or the table that you've just deleted the data from. So it really all goes pretty fast. The only thing that you need to do there is pay a little bit extra for an extra database that you just created, but that's only for a couple of seconds until you're done with the entire operation and you just can remove the database again. And that doesn't do anything to all the backups that you have. So you just restore the database that you just delete the database that you just created as a restore point. So there's no problem there. If you really want to have a full backup, I already mentioned through the means of Azure backup, the full bare metal backup that you can have. There's also another way of capturing your entire VM, And that's by means of capturing a full image. Now there's a little advantage here that if you want to reproduce your machine very fast, you can actually have an image that you can capture of an existing machine that you have today, and it captures the entire image, the entire machine with all the data disks included. So the cool thing is that it recreates an image, it puts it aside for you in the image vault, which you can then reuse to recreate another virtual machine, either with the same name or a different name, and recreate it as either a failover system or just as a secondary machine with the same exact settings and the same exact disks. Yeah? Of course, if you're redeploying it in the same network with the same name, you're gonna be in trouble. But it could be that you want to deploy the same kind of machine in a different region with all the same settings, that you just want to sift strip it afterwards. So you can either generalize it or specialize it. If you generalize it, you need to sysprep it before you capture it. But if you specialize it, you can just capture it and restore it by those means of a normal VM. Just like copying the VHD actually, but now with all the settings included. So that's a cool thing that you can do. That way, if your VHD fails for some kind of reason and it can be restored, you just can redeploy it by the means of the image that you captured before. Now, when we talk about moving your data to the cloud, there's another thing that you need to keep in mind. First of all, there's workload mitigation, and the cool thing about cloud is that it scales. Now, there's one thing that you need to keep in mind. Scaling is only up to the point where you have platform as a service. You cannot scale automatically a VM. Why is that? Because these are persistent, and because all these settings are unique, you cannot just scale them out. You can easily scale them up. That's no biggie there. So you can just go from an A1 to an A11 by figure of speech, or a D series, whatever. But you cannot redeploy multiple of the same VMs and make them scalable like that. Yeah. What you could do is provide cold standbys and scale them like that, or just recreate through the means of the image, put them next to that and put them in a farming model. For that you can emulate clustering features, but they will never be, how should I put it, they will never be auto-scalable. The only thing that you can do is create some VMs, put them on hot standby, and make them fan out that way, or cold standby if you prefer. Yeah? So that's a thing that you need to keep in mind. Yeah? So that's a little bit on high availability. If you talk about Active Geo Replica, if you talk about SQL database, you have geo replication that you can have. The cool thing is that if you have a primary region and a secondary region, most of the time they're bound through the means of the data sense. So, for instance, if you take Dublin as your primary region, Amsterdam will automatically become the secondary region, and vice versa. Yeah? Because these are region bound in Europe, and there's only one Europe that we have, and there's only 2 data centers there. North Europe is Dublin, Western Europe is Amsterdam. Yeah, go figure. There's a little bit of geography issue there. But if that primary region would fail, automatically your code will be transferred to the secondary region, and your database will also be automatically be filled over to that region. So the cool thing is that you don't have to do a lot of work there. It will automatically be moved over, and the only thing that you can see is a little bit of latency on the moment of failover, right? Then again, you can have, if you're doing SQL Server deployments on Azure VMs, you can either have a cloud always on availability group solution that you have, just as you have on premises. Yeah? And it can either be on-prem cloud or cloud, whatever you prefer. So that's the cool thing about always on. You can easily configure them that way. it's always on is the header solution by choice by Microsoft. Yeah? We also advise it because it's the better solution to have. Yeah? It's up to you that you to ensure that your database system processes the header capabilities that the service level agreement requires, of course. Yeah? It doesn't mean that Azure provides high availability mechanisms such as service healing for cloud service, that your databases aren't that you can meet ESLA by guarantee, right? You still need to make sure that your SQL Server itself has a good health when it comes down to your always-on availability group solution, right? Although keep in mind that the high availability mechanisms provided by Azure allow for downtime of the VMs due to events such as recovery from software or hardware failures or even system upgrades. So sometimes it happens that if you don't put your VMs in the availability set, it could be that there's some downtime in the data center when you deployed a single instance VM. Right? So you need to keep in mind, you need to keep that in mind. Of course, if that happens by means of updates or maintenance on the Azure platform, you will get a mail and you will be warned in advance. Yeah, but you need to keep that in mind. There's also the support for cloud mirroring solutions, where what you can do is you can just mirror it by means of the mirroring solutions that we have. And we can also have a hybrid scenario where we combine the always on and the mirroring and the log shipping, so that way you can have a full scalable solution in failover. Yeah? And from now on in SQL Server 2014, there's also an immediate capability of adding an Azure Replica immediately out of the box. So you don't need to do anything special anymore. You just can go through the wizard and just set it up as an Azure Replica immediately, and it will be created for you. So there's no lot of stress there anymore. Right? Do note that this needs to be done with the proper knowledge of the entire logging and mirroring and always on knowledge, of course. Yeah. We're talking about migration. SQL Server 2014 allows you to migrate your databases easily to an Azure VM, so there's not a lot of issue there. You just can either just move and pick up your SQL Server, tweak some stuff, and then get it up and running again in your cloud environment. What else you can do is you can also redeploy from within SQL Server, stating on your database, I want to deploy this to my Azure SQL VM, and then a full wizard will be activated, either creating a VM or either using a VM which is already there. So there's the capability of doing both of them. When it comes down to migrating a SQL Server database to an Azure SQL database running in an Azure SQL database server, there's a lot of capabilities that you can have there too. You can either export your backpack or your DACpack files and migrate like that, or you just can run through a wizard which allows you to recreate the entire database and copies all the data over the wire by means of database scripts. Now, do note that some of these will imply some updates upon clustered indexes or non-clustered indexes, depending on how your modeling has been done. Right? So you need to keep in mind that when designing a SQL database on SQL Azure, there's some inflections on whether your keys and your indexes are being put. That's only for matters of scalability and of performance. But these wizards will guide you and will advise you on where to change things. Yeah, so don't be afraid of doing those things, and if you're still in doubt, just call us. We will help you out. All right. So I already explained a little bit on the virtual machines itself. So it's just pick up and redeploy, or just from within the SQL Server itself. Right. Now that concludes our seminar. Just a small recap, a small conclusion that we have here. So we have built-in hybrid technologies in SQL Server 2014 easily connecting to Azure by means of pre-built Azure VMs, or always-on hybrid, always-on with Azure VMs as a always-on availability group, or even directly backing up to Azure Storage. It's all out of the box, so it's all integrated, disaster recovery solution, moving and migrating away from Azure, from on-prem even if you want to. So there's a capability here. Also, what you pay is what you use. So if you shut down your VMs in the weekend, you don't pay for them. I don't see why you would want to do that for a SQL Server, but there's this capability, of course, that you can have. Yeah, so it's really enterprise grade cloud. And when we talk about anything else for data services, well, you have relational and NoSQL database options in Azure. That's something we didn't talk about. It's not the focus of this talk, but you need to keep in mind that there's a lot of other capabilities the platform has. You have a GraphDB called DocumentDB and search capabilities, but you also have a very cheap NoSQL solution which is called Azure Table Storage, which allows you to store lots of data for a fraction of the price, which is based upon a key value pair scenario. If you want to analyze your data and you want to start mapping your data, you can also use HD Insights, which is there's also an integration path for SQL Server there. You can have stream analytics and event hopping, and you even have a nowadays machine learning on which you want to analyze and sentiment analyze your data if you really need it. So there's a lot of other capabilities in Azure than just these capabilities that we talked about during this webinar. So if there's no more questions, if there's no more remarks, there's only one thing that I need to say here is that if you have any more questions, just please contact us on these coordinates. You can follow us on Twitter, you can follow us on Facebook, take a look at our blogs at kohera.be. And with that being said, I thank you for listening. I hope you found it interesting, and we hope to see you on some other webinar. Bye bye. Thanks.